So hello everyone, how you guys are doing? Welcome you back. My name is Prakhar Shrivastava and today I am going to present you with the lecture on the non-traditional machining process. Now what we will be dealing with this in this particular lecture is about what is abrasive jet machining, what is ultrasonic machining, what is water jet machining. We will try to solve some of the questions from EDM and ECM process. And देखो, more or less 90% of the syllabus of non-traditional machining is also completed. Still, if you feel that you want to dig deep, you can refer to any book. The non-traditional machining process. Now, what we will be dealing with this in this particular lecture is about what is abrasive jet machining, what is ultrasonic machining. Yeah, the audio. Just a second. What is giving me two audios? I can listen to my own voice. Just let me check. By the time you guys can raise your doubt. Oh, ho, 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 ho. Just let me check in that what is the issue. I don't know why it is. Let other people join. Please share the message in your all group so that people can join in and then I can start with the lecture. Now I think that it is connected successfully. I'm really sorry for the reason that it got disconnected. Okay, chalo. So then without wasting any time, I will start with the lecture only. So hello everyone, my name is Prakhar Shrivastava. I have secured All India third rank in GATE 2016. Then I took admission into IIT Bombay and finally completed my masters from NITI Mumbai. From past, you can say, huh. From past 3 years I'm teaching with experience of teaching approximately 22,000 students. So thank you all for your love and support. And apart from that, the subjects that I deal with is industrial engineering, manufacturing technology, and engineering mathematics. So without wasting any time, let me give you a brief introduction to what is Plus platform. So Plus is a paid opportunity, or you can say the paid course given by Unacademy, where you will be getting the live classes, the crash courses, the rank improvement batch, the doubt solving lectures, the weekly test to monitor your growth, and all in all, you would be getting the complete preparation package. Complete preparation package. Complete preparation package. Secondly, if you go to the second offering, or you can say a higher version that is being provided by an academy, is the iconic subscription, where you will be getting the preparatory study material. A person will be allotted to you and he or she will be guiding you throughout the preparation part with us. Thirdly, you will also be provided with the study planner, what to study, how to study, and when to study. You would be provided with the booster session to keep your confidence up and you should be highly motivated. And finally, my personal favorite, the personalized test series. Now, personalized test analysis का क्या मतलब होता है? The personalized test analysis means that you give the test and we will help you to analyze that whether your tests, like what are your weak areas in the test, what are your strong areas in the test. ठीक है? And this is a quite easy topic, the topics that we are discussing, and फिर we'll be taking a break for 2-3 days, and then I will be starting with the crash course. That is manufacturing crash course, complete manufacturing crash course we will be starting. Okay, I hope that this is crystal clear to all of you. And I'm not able to see the comment, I'm not able to see certain things. चलो देखो, मशीनिंग टाइप के PYQs नहीं होंगे because PYQs are already done. Okay, we have solved so many questions from ECM, we have solved some question from EDM, we will solve 1 or 2 questions from EDM. Like I'll be giving you a question from EDM to solve, but the major part we will be covering is the abrasive jet machining theory part, water jet machining theory part, and ultrasonic machining theory part. Now what are the charges? So you have to pay around 27,225 rupees for 1 year, 34,650 for 18 months, 39,600 rupees for 2 years. Similarly, for iconic subscription, you have to pay 45,225 rupees for 1 year, 66,600 rupees for 2 years. But all these 5 costs that I have given you for plus for iconic are applicable only after you apply the code. Which code you need to apply? Prakhar 21. Only after you apply the code, these things are valid. And which code you need to apply? Which code you need to apply? The Prakhar 21 code. PRAKHAR 21. PRAKHAR 21. So let us start with today's lecture then. Okay? We'll start with the solid state machining process, but let us solve some questions from this. Take this question. During an electric discharge machining, ऐसा लिखो आप, during EDM drilling, during EDM drilling, during EDM drilling, 20 mm hole, 20 mm square hole, 20 mm square hole is made in 5 mm thick sheet. Absolutely clear? Thick sheet. No doubt till this point. The resistance of the EDM circuit is 10 ohm. Capacitance of the circuit is 10 microfarad. Okay, the gap maintained at such a value is voltage such that the voltage is 150 volt. The gap, that is intergap, that is the gap between the tool and the workpiece. The gap between the tool and the workpiece. Just a second. Okay, the gap maintained such that the voltage value is 150 volts. If the cycle time, that is the charging time of power supply is 0.7 milliseconds, 0.7 milliseconds, the power input is equal to, the power input is equal to अब जल्दी से बताइए. दिस इज अ वेरी इजी क्वेश्चन अगेन. आई विल गिव यू द माइंड मैप, यू डोंट वरी कार्तिकेयन. देखो मैं माइंड मैप सब चीजों के लिए दूंगा एंड आई एम गोइंग टू स्टार्ट आई थिंक फ्रॉम 10th of November. I am going to start with the crash course of manufacturing. I am going to start with the crash course of manufacturing. ठीक है, and it will take approximately 30 hours to revise it in detail. In this crash course, I will be giving you each and every mind map that you require. Don't worry about that. Like I have given you the forming mind map, I will give you the mind map of this also. Not a very big deal. Not a very big deal at all. At all, it is not necessary. Is it clear? I hope this is crystal clear to all of you. Now attempt this question. Attempt this question, it is required. Quickly try to attempt this question, guys. Quickly try to attempt this question. Whew. We have discussed that no, short notes and PYQs are not enough. Revising those short notes again and again and again and again and again and again, provided the short notes are made from, like, suppose for my like manufacturing. So for manufacturing, if you are attending these lectures generously and religiously and making short notes and practicing PYQs and practicing all those questions that I gave you, that is enough. See all the special classes and YouTube, more than enough. It will be more than enough. 160 watts. पावर और एनर्जी में फर्क होता है. 160 watts is the जवाब right answer, I think. Yes, very good. See, the formula for power is very simple. Power is given by half C discharge voltage square divided by time. If you consider this part only, this is the energy part. This is the energy part that is generated in EDM process. This is the energy part that is generated in EDM process to melt the workpiece. This is the part that is generated in EDM process to melt the workpiece. Yes or no? Yes or no, guys? Yes or no? Yes, sir. Bilkul, sir. Absolutely clear, sir. Absolutely clear. Yes or no? So you just solve this value 1 by 2 into 10 microfarad. Micro means 10 to the power minus 6 into 150 divided by time. Time is in milliseconds. So 0.7 into 10 to the power minus 3 seconds. And when you will solve this, approximately you will get what? You will get what? Now आप यूनिट बताओ इसकी. Oh sorry, VD ये स्क्वायर है ना. चलो, please tell me the unit. 160 watt, or you can say 0.16 kilowatt. This is the answer. This is the answer, and it is a very simple. मैं बता रहा हूँ. The questions are not difficult. If you don't believe, you pick up the question of previous 10-year paper. Pick up the questions of previous 10-year papers and try to solve. You will be able to solve almost 100% of the numericals. You will be able to solve almost 100% of the numerical. Is it clear? Because the questions are not tough. Why you want to study this much if you can do it in this much? Because do this much and revise it continuously. If you study this much, it will be very difficult for you to revise. I always ask my students, don't study much. Kam padho par bum padho. You need to study bum. You need to study it again and again. You need to practice it again and again. If you think that see, it is not, suppose this is a book. I have shown this book many a times to you. Now, only this much of book is required to crack the exam. Only this much is required to crack the exam. But I can teach you entire book. And then when I teach you entire book, it becomes your responsibility to revise this entire book. Will you be able to do that? No, you will leave this subject. You will leave this subject and then you will feel underconfident before going to the exam. यार मैंने तो अपना manufacturing किया ही नहीं है यार. I have not completed my manufacturing. I have not revised my notebook. If I teach you more, you won't be able to revise. If we can cover 90%, if in 100 hours we can cover 90% of the syllabus, why in 250 hours we will be covering 95% of the syllabus? Do you think this is situation is more beneficial or situation 2 is more beneficial? I want you to answer. Situation 1 is more beneficial or situation 2 is more beneficial? Quickly tell me, guys. Lathe का एक numerical देता हूं मैं. चलो, we will solve some lathe numerical today. Yes, Sam 2022. I will be making you solve some lathe numerical tailstock और वो सब headstock tailstock वाले numerical. I will make you solve. You need to understand that situation 1 is more beneficial. You need to understand that situation 1 is more beneficial because it is important. Because it is important for you to revise. Guys, I am requesting you this thing. If people teach you 250 hours, 3 hours of one subject, very detailed, very good teaching, very absolutely clear conceptual knowledge, but ask your faculty, sir, we want to crack the exam. Please teach us in that way so that we can revise. If you are not revising, you will not be able to crack exam. This all of us know. This all of us know. Then why we are not focusing? Why we are focusing on this much of content? Why you want 20 books for one subject? Why you want this package material, that package material? If you solve one package material, that is more than enough. If you take one test series and religiously follow it, revise it again and again, revise it again and again, you will be able to crack exam. But we want 40 test series, like we want 29 books, then we want this, then we want that, and at that point of time, at the later point, we are not able to finish the content and revision, so leave it. This is one golden words. I'm saying golden words. Study less, revise more. Or rather, not study less, study, like, try understand how to leave 10% of subject. Only study 90% of the subject and revise it. Only study 80 to 90% of the subject and start revising it. You should know what are the topics that you don't want to cover. Those are time consuming and are having very low probability to get, like, to be asked in the examination. Is it clear? Please don't do that. Please don't do that. Likho. An iron sheet is being electromachined using following parameter. अब आप इतने इजी से सॉल्व कर लोगे ना ये सारे प्रॉब्लम्स, इतने इजीली से सॉल्व कर लोगे ना आप. द डेंसिटी ऑफ आयरन इज 7.8 ग्राम पर सेंटीमीटर क्यूब. ठीक है, डेंसिटी इज डन. द वैल्यू ऑफ फैराडे इज, नाउ फैराडे का यूनिट क्या होता है, प्लीज राइट. एम्पियर मिनट. Ampere minute. Is it clear? If you multiply it with 60, it becomes ampere second. So always remember the unit of Faraday is, यार चल क्यों नहीं रहा है? अच्छा, अब मजा आया ना. Ampere minute. अरे सब कवर होगा. श्रीनिवास श्रीधर, that is my words. If you are attending that crash course, you would not be leaving any question from the numerical question from manufacturing. You will not be leaving any manufacturing question. That is my you can say my charge. Don't worry about that. No, Ayush Patak, I won't be taking industrial crash course. One new faculty is decided for you to take crash course. You will be letting know about him very soon. But you can always ask me industrial doubts. No issues. This manufacturing class is quite cool. You can obviously bring your normal doubts, general doubts, like you can say very normal doubts. Okay, your general knowledge doubt discussion we can have. And surprisingly, I want at least 60-70 students in that class. That is crash course. That is why I'll be promoting it properly, and you will be getting benefited. And I hope you have enjoyed all my courses till now: casting, metal cutting, forming, welding. In detail, we have discussed so many questions we have solved. I don't think you would be facing any issue. In manufacturing, कोई issue नहीं होगा. You won't be facing any issue. Ashwin B, you would be getting the lecture in English only. Don't worry. Clear enough? Now, please solve the question. For material removal rate, of 2 centimeter cube per minute, what is the value of, what is current? First solve this question, yaar. You will be getting it. Don't worry. हमने इलेक्ट्रॉन बीम मशीनिंग कर ली है ना, ठीक है. Let me start with abrasive jet machining then. Alchemist देखो, PI पोर्शन के लिए you just have to refer 2 books, PN Rao and PC Sharma. That's it. You religiously solve mostly though all. If you are following my lecture, almost that book is complete for you. Almost these books are literally complete for you. The analysis part. You just have to go through them again and again and again and again. That's it. But mechanical people don't even to require even to buy even a single book. Whatever I have taught you in manufacturing, that is more than enough. More than enough. That is the best possible thing you can do. I'm not going to tell you formula, Karthikeyan. If I've given you formula, I request and I expect from you people that you would be revising it. You would be making proper notes. If you don't know the formula, please turn around your notebook. You would be getting the formula. And if you have not written the formula when I have taught you this, then I'm really sorry, Karthikeyan. I cannot help you. That is crystal clear. Quickly try to solve it up. Quickly try to solve it up. Fatafat, quickly solve it. Then we will be starting with some cool concepts of solid state machining process. And you can say erosional. Solid state quickly. अरे यार ये क्या बात हुई? This is a direct question, guys. This is a absolutely direct question. This is an absolute direct question. Material removal rate is given by EI by F rho. EI by F rho. EI by F rho. Now you just need to apply the values. You will be getting the answer. This becomes ridiculous if you cannot solve this also. I is equal to MRR into F rho divided by E. MRR is given as 2 centimeter cube per minute. Faraday is given as 1609 ampere minute into density is given as 7.8 gram per centimeter cube divided by, now this centimeter cube, this minute and this minute goes off. We are only left with gram and ampere divided by the value of E is 56 divided by 2 gram. So gram and gram gets cancelled. The answer will be in amperes. Okay, when you will solve it, you would be getting the answer of I is equal to 896.43 ampere or approximately 900 ampere लिख देता हूँ मैं यहाँ. 900 ampere. This is the answer. This is the current that you need to have. This is the current that you need to have. This is the current that you need to have. ठीक है, चलो. Give the heading mechanical NTM processes. Chemical we have seen, electrochemical we have seen, thermal we have seen. Now it's the time. Chemical हो गया, electrochemical हो गया, thermal हो गया. ठीक है. Now it's time for mechanical NTM processes. So we need to study three processes under it. The first one is ultrasonic machining. Ultrasonic machining. The second one is abrasive jet machining. And if abrasive jet machining is advanced, it will go to water jet machining. It will go to water jet machining. It will go to water jet machining. So let us start our lecture with ultrasonic machining. Now, it's a very simple. All the three topics are almost theoretical. I will try to get you the numerical part if it is possible. But 90% of the time it is not asked in mechanical side. See, this is your transfer coil. This is your vibrator. Okay. And now you are having your workpiece here. This is a zoomed in situation. And here is your particles. Here are your these abrasive particles. Now, when the vibrator moves with the help of sonotron, the energy is transferred and it will do like this. It will do like this. And what will happen? That this material starts getting removed. This material starts getting machined. And hence the workpiece obtained looks like this. Suppose this is the part that we wanted to do. Is it clear? Is it clear to all of you? This is the part that we wanted to do. This is the part. This is the machined surface. This red color one is the machined surface. All of you understand that due to erosion, the material is getting removed. Due to erosion, material is getting removed. Due to erosion, the material is getting removed. So please start writing. It is the method. Please start writing. Make proper notes, guys. Make proper notes. It would be easy for you to revise. In this method, or see, right, in USM, ultrasonic machining को लिख रहे हैं. In USM, a slurry of abrasive grains is supplied between tool and workpiece. If you have not liked the video, please do like the video, guys. Is supplied between tool and workpiece. Okay, you guys are drawing the diagram. You can draw the diagram, not a very big deal. तो फिर ऐसा लिखो. Write it like this. ठीक है. Please draw it in the proper format now. Abrasive slurry, concentrator, sonotrode, abrasive slurry, workpiece, tool. Mark this as workpiece. Mark this as tool. Okay, clear enough? और क्या? The setup is similar. The non-traditional machining setups are almost similar to the welding setups. Okay, almost similar to welding setup. See, in welding, what we are doing? We are giving energy to break it, and then leave it to join. Then leave. See, we are giving energy for melting. Melting means breaking. Yes or no? And then leave it to get solidified. Now suppose if I am giving energy and I start on and keeps on going energy and I keeps on giving energy and I keeps on giving energy. Okay? And then as soon as it melts, I separate both the parts. Don't you think machining will be done? Don't you think machining will be done? Obviously it is similar to welding. Obviously this is similar to welding. Obviously this is absolutely similar to welding. You don't have to worry about that. Now please write in USM process the slurry of abrasive grains. The slurry of abrasive grains is supplied between tool and workpiece. 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 Due to vibration, the abrasive particle strikes on the workpiece. The abrasive particle strikes on the workpiece. Strikes on the workpiece. And material is removed in form of small chips. And material is removed in form of small chips. Material is removed in form of small chips. ठीक है. The abrasives are supplied along with the fluid. The abrasives are supplied along with the fluid. The abrasives are supplied along with the fluid. So that easy movement can take place. So that easy movement can take place. So that easy movement can take place. For example, benzene, oils, ठीक है, थोड़ा स्मूथ फ्लो बनाने के लिए होता है. Benzene, oil, ठीक है. अब देखो, प्लीज ट्राई टू फाइंड आउट Please try to understand that the force is applied on a very small area. The force is applied on a very small area. The force is applied on a very small area. ये बहुत छोटा सा एरिया है, दिख रहा है सबको? Now if this is very small, the force is applied on a very small area. The force is applied on a very small area. So pressure will be very high or stress will be very high. So that is why the workpiece have to face stress issues. Workpiece को stress हो जाता है. Why? Because the force is applied on a very small area. The force is applied on a very small area. Is it clear? Right. Due to the less or due to the small contact area, due to the small contact area, due to small contact area, the stress produced by the impact of abrasive particles, the stress produced by the impact of the abrasive particles is quite high, is quite high. Due to this stress, the material is getting detached from the workpiece. Due to this stress, the material started getting detached from the workpiece. Started getting detached from the workpiece. Now, in case of ductile material, this stress cannot be generated due to its shock absorbing capabilities. Capabilities होता है कि capabilities होता है? Option 1 लिख लो पहले. Now ductile material cannot be machined because the stresses are not generated due to its shock absorbing capability. Due to its shock absorbing capabilities. Ductile material में stress generate होगा क्या? Obviously not, because if you are applying the force, that force or that shock will be absorbed by the material, because that is what the property of ductile material is. So that is why ultrasonic machining is mostly used for brittle materials. Brittle materials. Now ऐसा होंगे एक दो ductile. It is not true that no ductile material can be machined from ultrasonic machining. This is the wrong statement. This is an absolutely wrong statement. No, nothing is just defined. That nahi matlab nahi. Some ductile material can also be machined, but we don't use ultrasonic machining to machine the ductile materials. Is it clear? We mostly use it for brittle materials because easily stress can be generated and erosion can take place. Chal. Is it clear? I hope that you have enjoyed it. Let us start with the parameters. अरे रुको अभी खत्म नहीं हुआ है अल्ट्रासोनिक मशीनिंग. Now you tell me, please tell me, with the increase in amplitude, will material removal rate increases or not? Amplitude is this movement. This movement is amplitude, the distance of this movement. This is amplitude. Quickly tell me. देखो एक मैं बताता हूं. Devarshi, please try to understand this thing that I am very fond of English. ऐसा नहीं है कि मैं इंग्लिश नहीं पसंद है, मुझे इंग्लिश भी बहुत पसंद है, लेकिन हाँ हिंदी और उर्दू मुझे उससे बहुत ज़्यादा पसंद है, बहुत ज़्यादा. आई एम मतलब आई लिसन टू दिस कव्वालीज एंड लाइक नुसरत साहब एंड देन बाबा फरीद, बहुत ज़्यादा सुनता हूँ मैं ये. ठीक है, जो पंजाबी उर्दू वाला एक्सेंट है ना, दैट इज आई लिटरली लाइक. लेकिन जहाँ तक इंग्लिश की बात आती है, इंग्लिश इज ऑल्सो वेरी गुड, वेरी वेरी गुड. Like suppose what is written here. What is written this? This is what? Option 1 you can say it idea. Option 1 people say it idea. Option 2 people say it is idea. Idea. It's my idea to break down the crystals into the fine structure and then prepare the casting. Like suppose it is my idea to get it down. Now that accent is different. This idea is one pronunciation and idea is one pronunciation. And idea, this is another pronunciation. Okay, so like for example, this is written as 11. So we call it as 11, but Scottish pronunciation of it is 11. So there is a video, there is a very good video in which a person gets stuck into the lift and like then stuck nahi hota, that actually lift work on your voice notes. So now he wants to go to the 11th floor, but what he is saying 11, 11, and the lift is not corresponding. Nothing, nothing. Now he wanted to say open, but they cannot say open because it is not their pronunciation. It's nothing, nothing. So that is why pronunciation is literally very very important, very very important. ऐसा बोलना सीखो यार. It's my turn, my idea to get it done. You no want to get it. चलो फालतू की चीज नहीं बताओ, यहाँ पे बकर होती रहेगी. फटाफट बताओ. That with the increase in amplitude, what will be the impact on material removal rate? What will be the impact on material removal rate? अच्छा अच्छा, ये भी ठीक है, आजकल तो नया है, ये भी ठीक है. अभी कुछ ऐसा इमीडिएट सोचे नहीं है, करते हैं प्लान. क्या करोगे गेट के बाद? अभी एकदम इमीडिएट सोचे नहीं है. Okay, so if you are saying you like suppose there is a guy who actually like try to flirt with your girlfriend and you go to beat him. Now you are having him down and you are like actually hitting him with the help of a stone. Now if you actually take a larger amplitude and try to hit him, don't you think it will hurt more? Don't you think it will hurt more, Mahadev Prasad? Don't you think it will hurt more? You are hitting like him like this, and you are hitting him like this. So do you understand the difference between the two? This is one thing, and hitting him from a distance. See, actually your hand gets momentum. The stone with the help of which you are beating him, that gives a momentum. The stone with the help of which, or the abrasive particles, or the tool with the help of which you are doing the machining, that gets the momentum. Or change in momentum is force, and change in momentum is what? Force. Rate of change of momentum ही तो force होता है. Rate of change of momentum is force. Now if your momentum is high, you are having a higher difference of momentum, so obviously your force will be more. If your force will be more, your material, you can say your material removal rate will be more. Yes or no? Yes or no? So this is the way in which it goes upwards. It goes upwards. Always remember it goes upwards. ठीक है? Now if the frequency is increased, please try to focus. If you increase the frequency, this curve shift upwards. Okay? So this is increased frequency. If I ask you between curve A and curve B, Whose frequency is more? Whose frequency is more? Whose frequency is more? Between A and B, whose frequency is more? Obviously, you will say that frequency A is more than B. So that is why, देखो, this is a 2D diagram. So you will get the relationship between MRR and amplitude at a fixed at a fixed frequency. You will get the relationship between MRR and amplitude at a fixed frequency. At a fixed frequency. At a fixed frequency. Now, अब ये बताओ. If you increase the grain size, what will be the impact on material removal rate? What will be the impact on material removal rate? If you increase your grain size, what will be the impact on your material removal rate? What is impact on your material removal rate? जल्दी से बताओ. जिएंगे मरेंगे 10 के लिए. Has anybody listened? Do anyone listen to the song of this band? Increase engineering. अच्छा, नाम ही engineering है. मुबारक हो, engineering हुई है. लोगों को 4 साल बाद भी नहीं मिल पा रहा. See, if you increase the grain size, obviously the impact will be more. That is no doubt, that is true. No doubt that is true. It goes up. So if you increase the grain size, your material removal rate increases. But if you increase the grain size to a more than a value, see, suppose it's just like filling a balloon. You are increasing the air in the balloon. It is increasing and it is more charming. It is more useful. But if you increase it beyond a value, the cracking capability comes in. The cracking or the fracture capability comes in. So that is why if you increase the grain size beyond a limit, it then starts decreasing. So it first goes up and then start getting down. You cannot, it is not necessary to increase the grain size. अब इतना बड़ा grain ले लोगे तो कौन सा वो machining कर देगा? The grain size should be very optimum. The grain size should be very optimum. Now third, with the change in frequency, what will be the impact on material removal rate? It goes like this. If you increase this frequency of hitting someone, obviously the pain will increase. The content will increase. Yes or no? Yes or no? Frequency is this. Tuck, 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 tuck. This is your frequency. The frequency is with which we are getting it repeated. Tuck, 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 tuck. This is high frequency. So obviously, if you are doing it like this, tuck, 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 again and again, force is applied. So obviously, the material removal rate will increase. Then we can say it goes like this. It goes upwards. Is it clear to all of you? These things you should know. These things you should absolutely know. Okay, give the heading abrasive jet machining. Second is abrasive jet machining. Abrasive jet machining. So, this is your workpiece. Here is your nozzle. Okay. Now, it will be connected to a box of compressed air. compressed air, compressed air. Is it clear? Here you will be having this is nothing but your abrasive grain feeder. Abrasive feeder. Abrasive feeder. Regulator, pressure regulator. Pressure regulator. ठीक है. This is what? This is mixing chamber. मिक्सिंग चेम्बर. इसके आगे नोजल लगा लो. दिस इज योर नोजल. This is your nozzle. Now what happens? Now what happens? That here you are having the abrasive grains. Here there is air. So here abrasive grains and air get mixed. And now the abrasive grains are fired onto this. So now due to this, here machining will happen. This material will be released. Okay. Now this distance is known as stand-off distance. This is known as stand-off distance. Stand-off distance. Application ultrasonic की लिख लो. बहुत सारी एप्लीकेशन होती है यार. देयर आर एन नंबर ऑफ एप्लीकेशन. इट इज यूज्ड इन डेंटल एप्लीकेशन. इट इज यूज्ड फॉर मशीनिंग ज्वेलरी एंड प्रीशियस स्टोन्स. इट इज यूज्ड फॉर मशीनिंग ज्वेलरी एंड प्रीशियस स्टोन्स. It is used for making dies, D-I-E-S, dies. Chalo. Now please draw this diagram for abrasive jet machining. Please draw this diagram for abrasive jet machining. Please draw this diagram for abrasive jet machining. देखो, मटेरियल रिमूवल इज ड्यू टू मटेरियल रिमूवल किसकी वजह से हो रहा है? व्हाट इज द मैकेनिकल ऑफ मटेरियल रिमूवल? erosion. Erosion done by abrasives. Erosion done by abrasives. Erosion done by abrasives. Erosion done by abrasives. Clear enough? Please start noting down. Please start noting down. I hope you have understood that entire. The compressed air will come, then abrasive will be met in that, and with the help of pressure, we are hitting it. We are hitting it on the workpiece surface. We are hitting it on the workpiece surface. We are hitting it on the workpiece surface. Now you can take the whole assembly as vertical also. Not a very big deal. You can take the entire assembly vertical also. Chalo likho. The basic principle of abrasive jet machining. The basic principle of abrasive jet machining The basic principle of abrasive jet machining is using high velocity stream using high velocity stream using high velocity stream of abrasive particles along with high pressure gas full stop. Compressor is used as first stage increase in pressure. And nozzle is used for second stage increase in pressure. For second stage increase in pressure, फिर ये वाली लाइन लिख लो. Material removal is done due to erosion done by the abrasives. Please note it down. कौन कौन सी एयर यूज होती है फॉर कंप्रेशन? So air, N2, CO2, these are used. N2, CO2, these are used. Now this process is also good for brittle materials. This process is also good for brittle materials. And mostly used for small amount of material removal. On an average, the pressure of gas is around 900 kMPa. ठीक है, kPa. 900 kPa. And the velocity of abrasives goes up to 310 meter per second. 310 meter per second. The nozzle is made up of tungsten carbide. Aditya, have you joined the lecture right now? Please see the video from the beginning, you will be able to understand. Likho. The nozzle is made up of tungsten carbide. The size of the abrasive varies between 10 to 50 mm. The size of abrasives varies between 10 to 15 mm. The size of abrasives varies between 10 to 15 mm. को समझ में नहीं आ रहा तो भाई मत अटेंड करो. 2 लोग आते हैं एकदम से नंबर ऑफ काउंट बढ़ता है. एंड नाउ अगर नहीं समझ में आ रहा तो 45 मिनट्स ऑफ लेक्चर के बाद क्यों बोला जा रहा है ये? इफ यू आर नॉट एबल टू अंडरस्टैंड देन स्टार्टिंग में बोलना था. Everyone understands that you have entered the lecture into midway and directly typing this comment. Don't try to make fool of yourself, mine or the other students. If you are not able to understand, and everyone in this lecture who are my current student, they know that every 15 minutes or every 10 minutes I ask, समझ में आया? सर समझ में नहीं आया और सर सुनाई भी नहीं देता है. Please try to write that the range abrasive size is in range of 10 to 50 mm. The abrasive size is in the range of 10 to 15 mm. The abrasive size is in the range of 10 to 50 mm. Due to the pressure of the air, please write, due to the pressure of the air, due to the pressure of the air, due to the pressure of the air, the sides of abrasive particle gets rounded off. देखो, more will be the pressure here, more will be the pressure here, more will be the force with which it's stuck, and more will be the machining. More will be the machining. Yes or no? Yes or no? Wait. Water jet machining में? Water jet machining में? We'll do that. Just a second. Where were we? See, more will be the pressure of compressed air, more will be the force with which it hits the workpiece, and more will be the machining. More will be the machining. But we cannot increase the pressure of the compressed gas. You know why? Because more will be the pressure of the compressed gas. Or compressed air or N2O2 जो भी है, compressed gas, it will round off the abrasive particles that it is carrying. Are you trying to understand? It will round off the abrasive particle it is carrying. Just a second, guys. You guys note down. Just a courier has visited. हाँ, ये चीज समझ में आ गई ना कि बहुत ज्यादा कंप्रेस्ड एयर का प्रेशर भी नहीं बढ़ाया जा सकता. चलो, ये भी बढ़िया सा हो गया. सब सही ही है भाई. लिखो, अब लिख लो अब्रेसिव वाटर जेट मशीनिंग. Abrasive water jet machining. You write it full form. You write it in full form. Abrasive water jet machining. See, in water jet, ऐसा लिखो, in water jet machining. In water jet machining, the change in momentum of water stream the change in momentum of water stream भाई ये तो इसको तो अपरिचित वाली दिक्कत है, मल्टीपल पर्सनैलिटी डिसऑर्डर। देखिए अपरिचित, देखिए किसी ने, भूला, वैसा वाला आदमी है यार ये तो। गोलमाल में भूला तो देखा होगा, भूला तो है यार, किसमें है भूला? भूला, जल्दी बताओ। हाँ तो भाई मस्त तो मैं पढ़ाता ही हूँ, उसमें क्या दिक्कत है? लिखो, इन वाटर जेट मशीनिंग, in water jet machining, the change in momentum of water stream or water jet stream लिख लो, the change in momentum of jet stream is used to create an impact, is used to create an impact भाई की तो आंखें भी नहीं है यार, अगर इसने इंट्रोडक्शन शुरू से पढ़ा होता तो पता चलता। कोई हंसेगा नहीं इस पे, देख ले भाई, इंट्रोडक्शन देख ले। नहीं तो बैठ, अटेंड कर लेक्चर और फिर पता चल जाएगा, जाते आते फिर बता दूंगा मैं। कॉन्ट्रैक्ट है भाई, सही में कॉन्ट्रैक्ट पे आते गए। इंजीनियरिंग करो, जॉब ना लगे तो यूट्यूब में दखलंदाजी करने के लिए पैकेजेस होते हैं, 5 रुपए दिन के पैकेज पे हायर हो जाते हैं बेचारे बच्चे। बैड यार, सीरियसली बैड। ये मजाक नहीं उड़ाते हैं देवर्षि, मजाक नहीं उड़ाना है, दैट इज बैड थिंग, नोबडी विल लाफ एट देम। चलो देखो, now the material removal rate is very low in water jet machining, the material removal rate is very low in water jet machining. The material removal rate is very low in water jet machining. So metallic, ऐसा लिखो, so metallic, non-metallic and advanced composites are not easy to machine, are not easy to machine, are not easy to machine. Are easy to machine. So we mix some abrasives like silicon on aluminium oxide. So we mix some abrasives like silicon and aluminium oxide in jet stream to make it more compatible. Sir, we have abrasive jet machining. Then why we are using water jet machining? What is the use of water jet machining? I don't understand. So if it is actually giving low rate, if it is actually giving very low material removal rate, sir, why we are using abrasive jet machining? Because beta, you need to understand that whenever there is a collision, the heat is generated. Yes or no? So when the abrasive particles and the compressed air is trying to hit this workpiece, it is generating heat. Now suppose this is a heat sensitive material. इसका तो खेल बच गया, इसका तो खेल हो गया ना. You understand? खेल हो गया का मतलब is now this is of no use. We are doing machining. This has paid the worker that please do my machining. And now if the worker is doing machining with the help of compressed air and abrasive water jet machine, abrasive machining, abrasive क्या बोलते हैं यार अपना, abrasive jet machining. So it will generate heat here, and he has paid the money, she has paid the money, and still the impact will be not good. The proper machining will not be done. Melting will take place. So that is why for heat sensitive material, we can compromise on our material removal rate, but we have to use water as a coolant. Now do you understand? Now do you understand this basic funda? Now do you understand this basic funda? Now do you understand this basic funda? If you understand this basic funda, you will realize that heat sensitive material cannot be machined using abrasive jet machining. Yes or no? So although my water jet machining is a vahyat process, it is not that good process, but yes, we have to use it because it is at least giving the cooling nature. It is at least giving the cooling nature. Please note down. But for heat sensitive material, but for heat sensitive material, but for heat sensitive material, we cannot use abrasive jet machining directly. We cannot use abrasive jet machining directly. And hence, as a coolant, water is also used as carrier. And hence, as a coolant, water is also used as carrier. Water is also used as carrier. Chalo. Is it clear to all of you? Now, फिर से वो समय आ गया है जब आपको अपना दिमाग लगाना है. अब now tell me, with the increase in standoff distance, with the increase in standoff distance, material removal rate will increase or decrease. Material removal rate will increase or decrease. With the increase in standoff distance, material removal rate will increase or decrease. जल्दी बताओ. नोट्स मैं नहीं दे पाऊंगा यार अंकुर कुमार. नोट्स मैं नहीं देता हूं. इट्स योर जॉब टू नोट इट डाउन, एंड व्हेन यू आर सीइंग योर नोटबुक इन योर हैंडराइटिंग, then only you can revise. This is a book, this is a notes made by PC Sharma. Will you be able to revise it? Literally, these are the notes made by PC Sharma. These are PC Sharma sir's notes, much better than my notes. Will you be able to revise? No, because these are someone else's notes. My notes are my notes, your notes are your notes. That's why I always ask, please do revise, please do revise, please do revise, and please make your own notes and in a fair notebook with a good handwriting so that you can revise. देखो, if you are increasing the standoff distance, initially there will be a very heavy decrease, very heavy decrease, very heavy decrease. ठीक है. If you are pulling, now this is the distance, if you are taking it away, obviously if you are taking it away, the flare will be more, the flare will be more. Yes or no? Suppose it is coming, so if it is quick, it goes like this. But if it is where it is at a distance, it will come and start covering a larger area. Now if the area is large, the accuracy will be less. The area is क्वेश्चंस भी जो मैं लगा रहा हूं दैट इज मोर देन इनफ. आई विल बी लॉन्चिंग द प्रैक्टिस टेस्ट, practice set of industrial I have already launched. Production I will launch very soon. That's it. That's what all you wanted to know. That is the everything you wanted to do. Please practice PYQ of IES and mechanical. अरे बताने बोलो, क्या नहीं बता देंगे? बताने को तो सब बता देंगे जो पता है, लेकिन समझो तो. No, that is decreasing. That is decreasing the standoff distance. That is decreasing the standoff distance. You have to understand your standoff distance. If you are decreasing, it goes on like this and it starts decreasing. It becomes constant. You know why? Because there is decrease in accuracy. 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 ठीक है, चलो अब बताओ साइज ऑफ अब्रासिव. Size of abrasive. Quickly tell me size of abrasive. With the increase in size of abrasive, it will increase, the material removal rate will increase or decrease. जो आप लोग इंक्रीज एंड डिक्रीज बोल रहे हो, जो आप ये वाले डायग्राम में इंक्रीज एंड डिक्रीज बोल रहे हो ना, इसका एक और डायग्राम मैं बताऊंगा. डोंट वरी, दिस विल इंक्रीज एंड डिक्रीज बट not with respect to accuracy. Always remember that. Whosoever is teaching you this thing or wherever you have read, that is wrong. Please try to understand. I will give you reason. With respect to accuracy, with the increase in standoff distance, the material removal rate is decreasing. I will give you the reason also where it will first increase and then decrease. I will give you the reason. But when I am asking with respect to accuracy, please be sure that it is decreasing. देखो, if the size of abrasive is increasing, your momentum is decreasing because it is directly proportional to mass. Yes or no? Your momentum will be increasing, but due to that, what will happen? The acceleration will decrease. If the weight is more, if the mass is more force is required to accelerate it. So that is why when you shoot, the acceleration will not be that much. If there is no acceleration, what will happen? What will happen? That force will be decreased. The impact will be decreased, and hence it will start decreasing the material removal rate. ठीक है, तो कई बुक्स में ये दिया होगा. देखो मैं बता रहा हूं ये, that with the increase in size of abrasive, the material removal rate increases. No, this is not true. With the increase in abrasive, obviously the impact will increase, but yes, after a point, the weight of abrasive starts creating a hindrance and acceleration decreases. Is it clear to all of you? I hope you are understanding it. Grain percent. Grain percent. जल्दी बताओ, व्हाट डू यू थिंक ग्रेन परसेंट के साथ क्या होगा? एसिम्प्टोट ही तो रहेगा ये. This is an asymptote because it will later point जब weight इतना ज़्यादा हो जाएगा that it cannot travel due to, if we are considering gravity, then it is an asymptote. If we are considering gravity, then it is an asymptote. If we are not considering gravity, then it is an asymptote. चलो देखो, when the number of grains increased, the point at which force is applied becomes more. If suppose there are 3 grains, 2 grains, it is hitting like this. Now there are 5 grains, it is hitting like this. So obviously from multiple area the material will be removed. So yes, with the increase in percentage of grain per unit volume, it increases. But again, if number of grains is too much, they will hindrance, आपस में ही टकरा जाएंगे while traveling. While traveling, they themselves get entangled, or like you can say themselves due to attrition. Attrition is that two abrasive grains are rubbing like this, due to which they are losing their cutting edge. Yes or no? Due to which they are losing their cutting edge. Now attrition, the word is attrition. Attrition means abrasion means due to some other surface. Suppose this is pen, it is getting rubbed against the wall, that is why it is getting the, like you can say, the dull edge. But suppose two pens are there, and while movement of all the abrasive particles, they are getting rubbed against each other, and due to which they are losing their cutting edge. It is known as attrition. It is known as attrition. It is known as attrition. So that is why due to attrition, the material removal rate starts decreasing. The material removal rate starts decreasing. Is it clear? And now, मैं इसी में बता रहा हूं that with the decrease in standoff distance, that is I am talking about this part now. I am only talking about this part now. ठीक है? Standoff distance. Okay. So with the decrease in standoff distance, the material removal rate first is it increases and then it decreases. समझ में आया? Are you trying to understand this zoom area? This is from O to A. This point is O and this point is A. And beyond which it goes like this. थोड़ा ज्यादा बन गया. Beyond this point, it follows our graph like this. Is it clear? It goes like this. Suppose, समझ में आया? So if someone asks you about what happens with the increase in standoff distance, so you will say it will decrease. Okay, and if somebody asks you what happens with the decrease in standoff distance, you will say it will first increase, that is going upwards, then becomes constant and then it decreases. Okay? Now no one is going to ask you at this point what happens with the increase in SOD. ये चिपक के खड़ा है. This is your workpiece, this is your nozzle. What happens if we increase standoff distance? You will say first it increases and then it decreases. Absolutely right. But this is not the way we are placing our situation. This is not the way we are placing anything. Yes or no? We are placing it like this. The initial position is this. The machining position is this. Now, if we are increasing it beyond this, it will decrease. If we are bringing it closer, it will first increase and then decreases. Is it clear? This is a very critical concept. Many books will directly show you this half. Many books will show you this half. But actual response is this, that from which point you are asking. Now suppose if I am asking what happens if we increase the number of grains, from this point if I am asking that what happens with the increase in number of grains, I will say it decreases. Now sir ने गलत पढ़ा दिया. सर ने गलत पढ़ा दिया, ऐसा नहीं होता है, बुक्स में तो इंक्रीजेस डिक्रीजेस लिखा है. Now try to understand, guys, that which is your reference plane. We all know that in this world everything is relative. Everything is relative. If I am teaching you, you will compare me with respect to some other faculty. I will compare you with respect to other batches or other students. Everything is relative. You have to define this point. You have to define this point. समझ में आया? चलो, this is done, and I think that I am done for the day. So thank you guys for watching the video. If you want to follow me, you can follow me on this particular channel, or rather you can say you can follow me on this particular link on Unacademy. You'd be getting some really cool concepts of manufacturing. That is the real life concept of manufacturing. Okay? And apart from that, I will be starting with the crash course on manufacturing from 10th. Crash course on manufacturing from 10th. Okay, so I hope you and your friends, I request all of you to join in that lecture. Okay, this is my Telegram channel along with my team. So you would be getting everything related to my team on this Telegram channel. Okay, this is a Facebook account. You can say this is the Facebook account and the Facebook group of our team or our of our team. Please do like the video, and apart, you are currently on Unacademy GATE MEPIXE. You should also visit Unacademy GATE questions because their previous year questions are written. And apart from that, thank you, all the best, hope to see you soon. If you have any doubt, please let me know. What do you mean by NLC? मैं समझा नहीं NLC क्या है. What do you mean by NLC? It will be like a crash course. अच्छा, नेवेली कॉप लिमिटेड. यार ये तो मुझे नेशनल लॉ कमीशन ज्यादा अच्छा लग रहा था एनएलसी का. अच्छा अच्छा, हाँ हाँ हाँ, आई नो आई नो आई नो. आई विल गेट बैक टू यू यार, मुझे ऐसा कुछ आइडिया है नहीं. नॉट अ वेरी बिग डील. चलो, we'll close this lecture. Thank you all. Let us meet tomorrow, and we will be wrapping up the metal cutting part of the machining and machine tool part, and then from 10th we will be starting with the crash course. Thank you, all the best. Hope to see you soon. Bye bye. शबा क्या, शुभ रात्रि नहीं, ये नहीं बोल रहा है क्या? कौन से टीवी चैनल में बोलते थे यार ये? इसमें तो बोलता था अमन यतन वर्मा. चलो गाइस, बाय बाय. थैंक यू, ऑल द बेस्ट.